let's go ahead and use L'Hopital's rule today to let's see what we are given. So prove that the limit as x approaches infinity of e to raised to the x power over x raised to the n power is equal to infinity for any positive integer n. So let's see what else. This shows that the exponential function, this one, approaches infinity faster than any power of x. So we want to show that this function approaches infinity faster, goes to infinity so much faster than this denominator, the x raised to the nth power. So to do this, we're gonna go ahead and use L'Hopital's rule. So right here is the limit again. Let's see, limit as x approaches infinity, e raised to the x over x raised to the nth power is equal to infinity. So first of all, we need to make sure if we can even use L'Hopital's rule. So let's go ahead and plug in infinity. So let's see, limit as x approaches infinity. There we go. Of x approaches infinity, and then let's plug in infinity. Infinity raised to the x power. Sorry about that. It is e raised to the infinity power over infinity raised to the nth power. So let's see what will that give us. E raised to the infinity power. This just goes to infinity, right? This one, infinity being raised to any power, just goes to infinity. And as you can see here, this we can use L'Hopital's rule for this. So since f and g are differentiable, since both of these we can take the derivative in order to use L'Hopital's rule. We need f and g are differentiable. So we can take the derivative of this one, and we can take the derivative of that one. So they are differentiable. So what else can we see? We see that this g of x does not equal 0. So that's another point. We can use L'Hopital's rule if g of x is not equal to 0. And we have plus or minus infinity over plus or minus infinity, or 0 over 0. And that's what we have here. So we can go, that's our third point. We can use L'Hopital's rule. So let's go ahead and use L'Hopital's rule. So let's see. Let's take the derivative. So this will be limit as x approaches infinity. The derivative of e to the x is just e to the x. The derivative of x raised to the n power, that's just we bring down the n. That's just bringing down the n. And then subtracting 1 from the n. So that is the first application of L'Hopital's rule. But as you see here, we can pretty much still get infinity if we plug in the number. Infinity times that is going to be infinity, and this raised to infinity. So let's go ahead and use L'Hopital's rule again. So let's go ahead and do it again. This is the second application. The limit as x approaches infinity of e raised to the x power, because the derivative of e raised to the x power is e raised to the x power, right? Doesn't change. So now we have n. We bring down the n minus 1, use the power rule, which is, and then we do x n minus 2, right? So n minus 1, let's put parentheses here. So let's go ahead and take the derivative just one more time. This is a limit as x approaches infinity of e raised to the x power n minus 1, bring down the n minus 2, and then multiply x n minus 3. So this is what we got. We got n minus 1, n minus 2, and so on and so forth. And if you keep doing this will just keep going on forever and ever, right? Now look at this. The e to the x stays the same, right? So f of x, which is e to the x, stays the same. Whatever stays the same. Now we have g of x. G of x. What's happening to g of x? G of x, well, the derivative of g of x and the derivative, so on and so forth, of g of x. What's happening? You see it's losing power. it's losing it's losing an exponent. So right here it lost 1, right here it lost 2, and right here it's losing 3. So loses I don't know, exponents. So it's losing the exponent. It's losing the power. So this is just for you guys to see. This is not like anything formal, but this is just for you guys to see what I'm trying to tell you. So this here is decreasing in power, and this here is staying the same. So as this goes up in power, this increases to infinity so much faster than this one. Why? Because it's decreasing in power. Look at this, it's decreasing. The more derivatives you take, the more it decreases in power. So now we can go ahead and write it down. So this is just right here. This is just for you guys to see what I'm trying to tell you guys. This is nothing formal. So let's go ahead and write down our answer. So as we continue to apply what? L'Hopital's rule. L'Hopital's rule. The numerator stays the same. Stays the same as the denominator decreases in power. As the denominator decreases in power. Right? So what else? Thus, the exponential function e raised to the x approaches infinity faster than what? Than any power of x, right? Any power of x for any positive integer n, right? For any positive integer n. All right, so let's see. So this is how we do it. L'Hopital's rule application. And then we come to the conclusion that as we continue to apply L'Hopital's rule, the numerator stays the same as the denominator decreases in power. Thus, the exponential function e raised to the x approaches infinity faster than any power of x for any positive integer n. So that is it. That is how we use L'Hopital's rule to prove this problem that we're given here.